So I wish that today I can verify all the things. Then you can go for the selected question for tutorial and try to answer it. Okay, let me start it now. Okay, starting which is we actually they quite confused for you the part of here, which is the N, L, ML, and the MS value. So today we go further. I give to you more example and how to answer it. Okay, before this, please remember about the symbol that we use for today's lesson. For example, N for principal, L for angular momentum quantum number, MS and L for the magnetic quantum. Okay, I remember magnetic. Then last one is S refer to the spin. Okay, so I using the symbol, you can refer back here later. Remember the two formula using it to calculate either orbital or either the number of electron. Okay, then afterward, we're using some of the concept, for example, Bohr, modern, Aufbau, Pauli, and Hart rules for the way that how we able to discuss it one by one. Okay, before this, we go for this video. Okay, I've showed to you this video. You just only have to know how the way should be. How can it be? Okay, still cannot be played. Okay, never mind. I go through the YouTube, then I will show to you later. Okay, give it to me 30 seconds. I try to play it. Okay, let me continue by the following part. The video can play. Okay, for example, this lamp actually like an electron. So let's say I spinning it, you can see that it's like a part. So this one actually go to the Born theory of quantum. Then let's say I circulate it like a form a sphere, a sphere. So this one is a modern theory of quantum number, or we call the atom. Yeah, how the movement. Okay, then afterwards, because some of the part that show to you the electron movement like 8, sleeping 8. Some of them is a vertical 8. Can you see the vertical 8? Okay, some of them getting to another direction or orientation, which is front and back. So this one actually under the P subcell, how the electron move in between the three of the subcell, or we call the orbital should be. Okay, this one just only tell you about the orientations of the electron movement. Okay, you can replay or you can go to the YouTube, then they will show to you more detail. Okay, this is like very important. Let me go to it one by one. Okay, for example, I'll show to you here. And let's say that we're having the principal equal to 1. So we know that the L, which angular number will be 0, cannot be equal to 1. It must be lower or lesser than 1. So 0. And if let's say it's a 2, then we can come up with two of the number, which is 0 and 1. If let's say 3, they come up with 0, 1, and 2. If let's say 4, 0, 1, 2, 3. If let's say 5, 0, 1, 2, 3, and 4. Clear? Okay, so this one actually representing we call the subcells, the subcell name. L, for example, that we have a 0, this one representing S. S for 0, 1 representing P. S, P, then followed by 2, D. Okay, then followed by here, we having is N equal to 4. They can able to give it to us the angular quantum number, which go to S, P, D, and F. Clear? Okay, so using the 0 of the S over here, so we can having the ML value equal directly to 0. You can observe all of them just only give to us 0 as a value for ML. However, if let's say L value is 1, then we got 3 of the orbital can be obtained. Hello, ML refer to orbital. The orbital can be obtained like 0, -1, and +1. How it representing? It representing here. This one's under the P. So we're having 3 of the ML value. This one actually representing the orbital. So which orbital? This orbital. Orbital 1, orbital 2, orbital 3 with the value of +1, 0, -1. Is it clear? S, 0, strictly nothing. So when we go for 0, it refers to the center, -1, +1, and this one we call orbital. Clear? More further, if let's say we go to upper part, it's a 3, 0 is S. So 3S representing the orbital over here, 3S. Meanwhile, when we go for P, 3P. 3P, we're having three value of the ML, which is 0, +1, and -1. So this one refers to the 3P subcell. So we can write down 0, -1, +1. However, if let's say we go to higher, which is value of L equal to 2, it can be 5 orbital of ML value, which are 0, -1, +1, -2, +2. How many? Yes, total 5 orbitals. It representing like here, 3D with 5. Which 5? 0, -1, +1, -2, +2. Okay, so this one to show to you how the orientations of the simple electron, which is from starting 1s, 2s, 2p, 3s, 3p, and 3d subcell. I repeat, subcell. So if let's say you want to go further for the 4s, then we know 4s representing by 0, then you're having a box. So the box representing by 4s, and followed by P value that we have. Hey, how many boxes should be? Yes, 3 boxes. So we can able to draw the subcell of 3, 1, 2, and 3. What's the value for the ML? Yes, we're having 0, -1, +1. So this one is strictly 0, nothing to do. And let's say we label is a 4P, and we can go to 4D. Then 4D over here, 4D. So how many orbital will be? 1, 2, 3, 4, 5. 5 boxes. So 5 boxes. So now we can able to draw the boxes as well. 1, 2, 3, 4. And we're having is 4D, which is 0, -1, +1, -2, +2. Yes. And then from here, we can able to allocate the electron. Yeah. Okay. Somebody say, Mr. Ling, is it ended already for the 4? N equal to 4? No, because we got one more, which is here. 4, which is L value angular with number of 3. So 3 over here is F. F, that means we can having a higher possibility for ML, which is 0, -1, +1, -2, +2, -3, +3. How many boxes of the orbital will be? 1, 2, 3, 4, 5, 6, 7. 7. So you can able to draw here 7 boxes. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So let's say you want to label, you can label it here. This is 0, -1, +1, -2, +2, -3, +3. So this one is the way how we draw the orbital in box diagram. Okay, okay. So now it depends on the atom. The atom itself, you must refer quickly to the atomic number. For example, hydrogen, atomic number equal to 1. So the mean 1 electron allocate at the 1s with one single electron. One only, Go to helium, we got 2. So we got go for 2 spin, one going up the spin, face up, another one must be downward, because you have to follow a rules later. If let's say you draw the boxes and you put the spin all with the same direction, we give to you 0 mark, because you not, or we call you against the rules of the principle to give electron in the box diagram. Clear? Okay. Then go further. Let's say the electron getting higher number. For example, okay, we got chlorine, which is totally 17 electron. So you can fulfill by electron 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This one consider empty. You must draw the boxes also. Yeah. But in case that the subcell for D really none of the electron, you no need to draw the box. No need. It just only stop at 3p. I give you an example later. Okay, so far any problem? Anyone want to ask question? You can ask me now.
Teacher.
Yeah.
So under the box, we need to write 1s, 2s, 2p like this.
Okay, good question. Okay, any more question? Any more? No, no. Okay, so thank you very much for you asking questions. In the way that we draw the box diagram for the electronic configuration, normally is we starting to draw a box. Hey, listen, when the question come out, it asks you to draw a box, you must draw a box. But somehow some student you put underline, tak boleh. This answer will be rejected. You must totally draw the boxes and show the boxes as well. So that means during exam, please bring along a ruler. Then this is, for example, we know it's a 1S, and this is under 2. Sorry, I need to redraw. Okay, so this one is a 1S. So this is under 2S, then followed by 2P. So it depends to all the number of the electron. For example, the first one you occupy, so you can able to put 1, then followed by 2. And this is just only 2S, nothing to do, also 2 electron, 1 and 2. When go for 2P, so once again, you no need, I repeat, no need to label +1, -1, 0 over here. No need. No need. Okay, you just only have to write down the subcell name 2p. Enough. Okay, then afterward, you draw the electron based on the principle. Let's say we got totally number of electron which is equal to 10. 10. So you must know about 1s will occupy for 2 electron in the same orbital. 2s also 2 electron in the orbital. 2 electrons. When you go to 2p, when you fill an electron, you must fill in like here. 1 up, another one must be up at the second orbital. Another one should go to the third up. The fourth, you back to here, downward, and followed by the center, the fifth, and followed by the sixth. This one is a rule that we have to obey based on the 3 principles I will show to you later. You must know, so they mean when you want to fill in electron in the same of the subcell, you must fill in parallelly first. Parallelly, they mean from here, which is 1, 2, 3, 4, 5, 6, 7, downward. 8, 9, 10, 11, 12, 14, and 13 and 14. So this is the way how you fill in electron. Okay, somehow some students they make a mistake when they fill electron, for example, 4 electron, they draw right here. Hey, sorry, for example, 2 electron, they draw right here. Sorry, strictly 0 mark because you against one of the rules to fill in electron. Okay, somehow some students they draw for the 3 electron, they draw like here also. 1, 2, then 3 downward. Also wrong. This one also consider 0 mark. Okay, now we have to go for one by one to know why and how to explain. You must obey based on the 3 principles. Okay, before we go proceed, any question you want to ask? Anything? No? No? Okay, no, then we proceed to the following part. Okay, can you please tell me what is the question we ask you normally? Normally, the question will ask you, give the electronic configuration. Be careful. You must know about the format. Electronic configuration in orbital box. You have the name of box. You must draw all the boxes based on the subcell. So label 1s, 2s, 2p, 3s, 3p, 3d to the maximum electron of the atom, or we call the ion. Be careful. Sometimes the question will ask you atom. Some of the question will ask you ion. If let's say it's a positive ion, it means based on the atomic number, it's getting lesser. For example, okay, sodium. Sodium, we got 11. So when the 11 fill in, you can fill in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then 11 over here. But however, when it becomes sodium plus, 11 still remain because atomic number won't change. But the electron number we're getting lesser. Proton number is atomic number won't change, but we have to do calculation. 1 electron being donated, left over equal to 10. So which are the 10? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Done already. The rest, no need to draw. Okay, and afterward, must label properly based on the subcell. But don't be busybody. I say, don't be busybody to do right 2 here. You put 2 over here. Uh-oh. We give to you wrong already. Wrong in what? Wrong in format. Remember, question quite simple, answer very simple. But when you answer, you must based on the format. You cannot having your own idea, then you come out and come argue, sir, give PT mark lah, correct what? We call it, sorry, you're wrong in format. We can't give to you any mark. Yeah, so you have to, what to do? You must know about how to answer it correctly. Get it? Okay, so this is under chlorine, under sodium. If let's say the question come up, we ask you based on the chlorine, then how is it? If let's say it's chlorine, for example, chlorine that we're having 17 electron. So you're having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, stop over here already. This one don't have, so this one we know under chlorine in atom. But however, when become chloride, even though it's a 17, show you atomic number, but one more electron being added. So how many electrons overall? 18. 18. That means this electron will be included in the electronic configuration. Sini, this one. Here, this one are included. Okay. Another thing, some of the book, if you, let's say you refer, they can able to show to you electron in here, this one. Okay, among our lecturer, actually we accepted already because in organic chemistry, this one representing 2 electron. But in inorganic, normally is show this arrow to show a single electron will be accepted. So some of the book they're using single, we call half spin. And this one we call half spin. They draw like here. In this case, we accept also both. Understand? This one I verify here because when you refer to some of the book, you're getting, sir, Mr. Lim, how can this one got half spin, the other one got full spin? Which one correct? Both are correct. And okay, this under orbital box. Another format you ask you under SPDF. Why? Because using S and P, then D and F to representing the orientations of the electronic configuration. So you have to write down, this time you must write down 1s with 2 electron, 2s with 2 electron, 2p with a 6, 3s with a 2, then 3p, let's say chlorine, 3p, 5. 3p5. Okay, you want to ensure that easy for the same of the principal n, so you can total up the number 2 plus 5. For example, 2 plus 5 equal to 7. We know that chlorine from group 7 or group 17. So this one can do a check. Get it? Okay, so this is a simple way. Please follow the instruction either on orbital box or under SPDF notation. Okay, now before we proceed, any question to ask? No, we proceed. Okay. Actually, it's during the lecture I like to teach, but the problem is during that time it's under hybrid mode. We are really do know because all the time we are sending in front of the whiteboard to write. So in hybrid mode, you have to write using writing pad. That's a problem for me because it's not easy to conduct. Okay. Now we go for it. Yeah. What is it?
I thought 4S should come first before the 3D.
Later. This one's under another higher level. So I just stop over here first to roughly tell you. Good question. Okay, some student will ask me, Mr. Lim, if they say we're having 4S, it's a 4S2, is it must be 4S2 first before 3D? The answer is yes. But during your test 1, we won't cover until 4S. Relax. Okay. Until chapter 9, then you have to know about the allocate for the 4S in electronic configuration. Okay. So for test 1, don't ask first. We ask during the test our final exam. I will verify it afterward.
Teacher, I'd like to
Yeah.
ask a question.
Uh-huh.
Normally, if example, like for instance, if it's example, the electron configuration is 2s2, so the N is 2, the L is 0, the ML is 0. What about the MS? Is it also nothing, or it depends on the electron?
It depends to the number of electron.
Ah,
Number of
but the
electron.
S only can allocate 2 electrons. So there is an MS spin, right? Either positive 102 or negative 102, right?
It depends on the question itself. For example, that you have to verify, is it under a metal or under a non-metal element? For example, that we know that, for example, in the metal, for example, magnesium. Magnesium, we got totally 12. Atomic number is a 12. We know that 12 proton, 12 electron in the atom. Normal, no charge. But when it become magnesium is a magnesium 2 plus, the number still remaining as an atomic number. Proton won't change, but the change in what? The number of electron. So what's the number of electron will be? Equal to 10. Okay, because 2 electron being donated to form ion. However, for oxygen, for example, oxygen from, totally we got 6 electron. Okay, 6 proton in the atom. But however, when you form oxide ion, still remaining 6, but now the electron number will be different. How many electrons will be? Equal to 8. Why 8? Because 2 electrons being added into the atom to form ion. So that's why you have to base on 8 or 10 to draw the electronic configuration, either orbital, box, or either SPDF notation. Can I answer you?
Teacher, I give an example. Example, for barium, there's a total electrons of 4. So I want to know the magnetic spin of it, because it's the electron configuration SPDF is 1s2 and 2s2. So of course N is 2, L is 0, ML is 0. What about the MS? It's will still have a value, right? Even though ML is 0, right?
Okay, don't worry. The following part I will tell you.
Okay.
Okay, wait for a while. Okay, any questions so far about the electronic configurations so far? Okay, later I'll answer this question in the following part. Okay, so once again to repeat, look at the question. The question stated there, write the electronic configuration for chlorine. For we got totally 17 as an atomic number. 17 proton, 17 electron. Check properly. This is for what? Chlorine. Selamat. It's not chloride. If let's say chloride, you have to know 1 electron being added. Totally 18 electron. But now this chlorine is atom, no issue. Use 17 to draw, show off. Okay, then we have totally 4 format. You must be careful. Because why? Normally we're having SPDF notation. Some orbital box notation. But somehow, some question that come up is noble gas. And also noble gas, you must be careful. Okay, so what should you do? We just starting from the SPDF normal way. Chlorine ... write down the electron based on the number that we have. So some students say, Mr. Lim, is it this one important or not? This one actually is optional. You want to write? Up to you. You don't want to write? Direct answer, no problem. We will accept it. Okay. Then afterward, when we go for the noble gas, you must be careful because why? You have to choose the most nearest number of normal gas. 2 for helium, 10 for neon, 18 for argon. So you have to choose, yes, neon as a 10. So which one representing neon? Here. This one is a neon. Yeah, totally 10. So left over, you can write it as a valence electron number. So that's why this one you convert it become normal gas SPDF. So this one will carry to you 2 marks. Be careful. Don't simply contribute your 2 marks. Be careful with the format. Normal gas, neon. Neon, please put in bracket. But somehow some students, I don't know, they like to change their own format. This one actually we will accept it. But normally we prefer that you put bracket in the box. Here, okay, but don't this say Mr. Lim say put in the box, so we put all the thing in the box. No such way. Column in box. Okay, neon then followed by the valence electron number. Totally 7. Yeah. So some students very careless. They are so rushed, you know, they don't care about it. So I wish that at the starting, please write in SPDF. Use pencil quickly, because in your final exam last semester, you got the booklet, isn't it? Actually, booklet, they got 2 pages. This one for rough. Up to you. You want to draw, you want to write, we want to calculate, up to you. But this one not counted. So you can write anything here as a rough. But you transfer your answer into the right. This one we mark as an answer. So you just, this one, take it as a rough. Then you just write down your answer toward, let me transfer to the right. Get it? Okay. Next one. Orbital box notation. Yes, we done already. All the things just follow the sequence. Don't be busybody to put number. Once again, don't put 1s2. You 1s2, totally we give 0 mark. This one's under our agreement among the lecturer already. Don't give any mark. Careless. Okay. Then once again, this one we show to you the noble gas notation. So that's why we can representing like Ne bracket. Then all the boxes by the orbital of the subcell. Okay, so far any problem about electronic configuration?
Teacher,
Yeah. Pass.
just now you say the 4S will be in front of the 3D, right?
Correct.
But when the question doesn't have 4S, but he until 3D, so we just write 3S first and then 3P and then 3D.
Okay. Now I'm talking about test one. Test one, once again, we won't involve 4S and 3D. We won't. But when we go for final, one question will ask you, but if let's say undergoing, once again, if let's say under your final exam, you want to write down, it should be 3D first, then followed by 4S. 3D, 4S. Even though the electron will fill in 4S, then followed by 3D. But we have to follow the alphabetical, or we call numerical, from the lower to the upper. Clear? Okay, once again, somebody still confused already. I repeat, even those in the we call energy level, 4S will be lower than 3D. So the electron on the 4S we will fill in first before 3D. But in the electronic configuration writing, you must having 3D first, then followed by 4S. So your answer will be 3D, for example, 5, 4S will be 2. This one is a normal case. It's a correct format. Okay, next question.
Teacher, that means when we arrange, we will arrange 3s2, 3p5, then 4s2 only until 3d5.
No.
Correct?
Must be having 3D first before 4s2. You must having the lower numerical to the upper numerical. 3 followed by 4. Even though electron fill in 4s first, even. But writing must having the lower number to the upper number. Okay, this one I will discuss during chapter number 9. So don't worry first. You just only cover until here, until 3P6 cukup for your test 1. And the rest, we go for topic 9, we discuss more further. Okay, I hold first, I hold it first. Okay, don't worry, we're having 3 months to meet. I will let you know about after 2 or 3 months. Okay, any question?
Teacher.
Yeah.
If this question is correct, then if the question asks us to write the noble gas SPDF notation, can I just write the bracket AR?
Yes, correct. Okay, let's say you're having is a chloride. Chloride, we know the number of electron from 17 become 18. 18 refer to argon. So you just only write down bracket argon and the story. Let's say the question asks you, give in noble gas SPDF. Clear?
Okay.
Yeah, correct. Okay, next one. Any more?
Teacher, when we answer electronic configuration, that time do we need to write CLZ equals to 17 like this? That means we need to write the proton number out.
This one, isn't it? This one, isn't it?
No, the CL then bracket Z equals to 17. Do we need to write this one, this step out to show that
Okay.
the
Okay, this one also optional. So if let's say you want to write, doesn't matter, no contribute any mark. If let's say you don't write it, just write out bracket AL, then we consider correct because we are focused on here as answer. This one just only refer to the question. Okay, this one is a question. You refer to question, nothing, no mark. Okay, any more question before we proceed? Can? Okay, once again, Cl atom and chloride atom dot dot, this one is optional. You want to write? Doesn't matter. You don't write? Doesn't matter. No mark also, okay, before the writing. Okay, now we go for the question. Okay, can? Okay, let me go. Is the following orbital existing? If let's say this question come out, how you answer? For example, that we refer to the n we have. So n equal to 3, then L will become out is 0, 1, and 2. See my writing pad come again, the problem. Okay, once again, okay, I repeat. N equal to 3, then the L number will be 0, 1, and 2. Okay, 0, 1, and 2. Then this one will show to you how the orientation. And the ML value, we can go for the highest, which is 2. 2, okay, 0, 1, 2, 0, S. 1, P. 2, D. Okay, is it possible we come up with 3G, 3G, 3S? Yes. 3P? Yes. 3D? Yes. 3G? No, cannot. So how you answer? Here. 3G orbital cannot exceed. This one, 1 mark. Oh, you said that no exit mark. Okay, 1 mark. We agree. But you put can exit, it's a problem. Wrong already, totally wrong. What? Because N3 shall consist. Result. You didn't forget to put the cell, doesn't matter. You put, because n equal to 3, just consists SPD subcell. Enough. Then you want, let's say you want to further, but not G subcell. Also doesn't matter. We will accept it. Clear? Okay, so once again, 3G cannot exist 1 mark because only SPD subcell. This one another mark. Get it? Okay, now we go to 5D. 5D, then n equal to 5, then we know that L value can be 0, 1, 2, 3, and 4. Then write it down. 0, S, 1, P, 2, D, 3, F, 4, G. Okay, 5D, is it exit? Yes, 5D over here, 5D, 5D. Yes, so we can write down, yes, 5D. Yes, 5D exits. Okay, going to write down because when n equal to 5, so the subcell, sorry, really, I have to change my writing pad. Okay, subcell of what? Of S, P, D, F, G exists or God consists. So this is the way how you answer the question. Is it clear? Clear? Okay, so any question I want to ask here? Okay. So sorry about the writing pad problem. I had to collect some angbao from my kid. After I can go to buy a new writing pad. I wish that a new writing pad can be used after Chinese New Year. No need, because back to our normal physical mode. Okay, good. What is the orbital number in subcell of 4p? Then quickly call orbital. They got 2 formula that we use. Which are the 2 formula? So orbital equal to 2L plus 1. Okay, so 4p, we know that. Quickly write down. S equal to 0. 1 equal to P. D equal to T. 2. Okay, then afterward, F equal to 3. Okay, call P equal to 1 over here. So just substitute lah. the number which is 2 times 1 plus 1. So equal to 3. So right now, 4p consider 3 orbitals. Clear? Clear. Okay, next one. What is the orbital number of shell of 5? So what's the formula? We're having a formula. So the orbital number which is equal to n power of 2. Okay, so 5 over here. So we can able to write down 5 equal to 25 orbital. Okay, so far any question want to ask? Sorry, you can having a rough paper, you write it down your solution. Yeah, rather than you just only refer to my slide. No problem, okay, no problem, we proceed. Okay, what is electron number in subcell 5D sub of 3? So I give it to you 1 minute to calculate. Okay, let's try before I give to you the answer directly. Okay, come. 1 minute from now. Okay, let me go for it. Number of electron, be careful, because it's not number of orbital. So 5D, D, what's the number representing? 5D equal to 2. Be careful, write it down, 2. So we're having is electron number, electron equal to 2L plus 1 bracket 2. Okay, so you substitute into here. So we come up with 2, 2, 4 plus 1, 5 equal to 10. 10 what? 10 electrons. Are you correct? Is it correct? Good. Yeah. Shell equal to 3. Then we will go for it. So the electron number equal to n power 2, but 2 times. So we can come up with the answer 9 times 2, 18. 18 electrons. Are you correct? Yes, okay. So far, any problem before we proceed? No, no, okay. No, then we proceed. Good. So once again, to tell you about some of the verification for the terms. For example, shall. Shall n equal to 1, it just only refer to 1. 1 is a 1s. If let's say shall equal to 2 is a 2. 2s, 2p. They are under the same set, same shall. If let's say shall equal to n equal to 3, we got totally how many? 3s, 3p, and some students say, Mr. Lim, how about 3D? Yes, 3D also included. Okay, this one we call shell. Subshell, it refers to the shell that we have. For example, 2s, even though is under the same of the shell, but they got partition, they got sub. So it's having 2 subcell. Subcell of 2s, subcell of 2p. Okay, so then if let's say 1s, Mr. Lim, 1s is considered subcell of cell. You can say that it's a cell, you can say it's a subcell. Because of why? Subcell actually more than 2 combined to become a cell, or maybe 2, or maybe 3, or maybe 4, or etc. Yeah, but single, we normally wouldn't say subcell. We wouldn't say, we will say it as a cell. Okay, so how many subcell for 3? How many subcell for 3? N equal to 3? Yes, we got 3. 3s subcell, 3p subcell, and 3d subcell. Clear? Okay, let's say 4. Yes, we got totally 4 subcell for n equal to 4. Okay, next one. Orbital. Orbital refer to either subcell, cell, it's just only occupied by a box. Okay, here, for example, that we're having through P, that we're having orbital 1, 2, and 3. So this one we call orbital. So orbital can consist two spins, or maximum two spin, or consonant can be zero, can be zero. So this one we call orbital. 3s also we call as a cell. Okay, can call as a cell. Okay, seldom we use subcell, seldom because it's a single. And okay, also we can call it as a 3s orbital. Can also, because of why is qualified. As a box consists two electrons in the box. Clear? Clear? Okay, for example, just now we calculate what is the orbital number of, for example, 3p. Did you remember? P representing as 1, isn't it? So what is it? 2L plus 1 to calculate. So this one equal to 3. 3 orbital. Which are the 3 orbital? This orbital number 1, orbital number 2, and orbital number 3. See? Okay, let's say you want to know about the number of electron. So this one under orbital. Okay. Let's say you want to calculate for number of electron. So with 2 times for it plus 1. So number of electron equal to 6. So this one is a number of maximum electron in the 3p subcell. So 6. Where are the 6? 1, 2, 3, 4, 5, 6. The maximum electron in the 3p subcell. Clear? So that's why during exam, if they say, Mr. Lim, sometimes I'm weak in calculation. Can I set it directly equal to 6? I say can. Because of why? You can use draw here to calculate. But drawing sometimes take time, so it depends on yourself. And okay, then spin number upper positive half. Must put half positive, must put. If let's say lower, negative half. Must put. Okay, then afterward, we go for the last, which we call the core electron. Core electron, valence electron. How you know? Listen, valence electron refer to the most outer n number. The most outer n number. N equal to 3. 3 and the 3D here. So we refer to here, this one is totally the number, it becomes the valence electron. Yeah, the most don't choose 3, let's say 3p here, don't choose 3p as the outermost of the valence electron. Tak boleh, you must refer to the most outer n number. Okay, let's say this is under valence, the rest consider core, dalam. Okay, dalam that means this overall electron number will be calculated. Boleh faham? Boleh Any question? No?
Teacher,
Yeah.
the valence electron and the last valence electron are the same meaning.
Okay. Thank you. If let's say it's under valence electron, it refers to the outermost n, outermost s, n number. For example, here we having 3, n equal to 3. So the overall here we call valence electron. But if let's say the question comes up with the last valence electrons, then it refers to the most outer. The last one with a negative spin here. Yeah, it's under 3D, the last one here. Okay, or otherwise, some of the question we give to you, what is the last valence electrons of 3p? Refer to here, 3p. This is the last. So you, during exam, don't rush to answer. Read the question properly, understand about what the question means before you answer. Can Okay, this one later I give to you one example. So far, any question want to ask before we proceed? No, no, okay. Now we proceed to, ask.
I want to ask, usually if we the valence electron is the 3, right? The n is equals to 3, right?
Yes, correct.
So if let's say to list the quantum numbers, we refer to 3p, right?
Later, this following slide I will tell you. Okay,
alright.
Okay, hold on first, hold you first. Okay, come, now we go for the question here. Okay, what is the electronic configuration of sulfur S in, let's say this question come out, what should you do? Don't be rushed, quickly go to the periodic table and do a check. Mana itu sulfur sulfur S. So how many electron will be? 16. Put S. And check this one refer to sulfur, not sulfide ion not ion. So it's an atom. It's atom 16. Then you say, oh, selamat. We have correct already. Then SPDF. Any normal? No normal no normal. Then we can write it dot dot. Up to you. Want to write? Should be okay. 1s2, 2s2, 2p6. From here I will stop because of why? This one equal to 10. 10, they may left over. Oh, I know that the leftover, which is equal to 6 more, is a consider valence electron. So what should you do? 3s, I got 2, then followed by 3p. How many that I have? I got 4. Understand? And then I do a check. Valence electron, which is 2 plus 4 equal to 6. I know that sulfur from group 6 or 16 in the periodic table. Logical thinking, yes or no? Yes, my answer is correct. Clear? Clear? Okay. Selamat. Any notation? Any normal gas? No, selamat. Go ahead. Okay. Normal gas orbital box. Have to go for box. So what should you do? I have to do the box. But I got normal gas. What's the nearest number of it? Yes, this is the normal gas. Okay, number that we have. 622 equal to 10. So equal to what? Equal to argon. Yeah, argon. So that's why, is it correct or not? This answer? Is it correct? Can somebody answer me? Correct or wrong? Hello?
Wrong.
Wrong. Very good. Wrong. Why wrong? Because why? It's stated here normal gas. So the normal gas we will be representing here. Yeah, so you have to write properly with the sulfur, then followed by a black cat. So where's the number? Is it argon or neon? Can somebody check for me? Can somebody check for me? Argon or neon?
Argon or neon. Neon.
In neon, neon. Sure, okay. Neon is a 10 electron. Then followed by the box that we have. Draw the box for 3s, write down, and followed by the spin. 1, 2. And followed by the following 3p subcell. How many left over? 4 we have. 1, 2, 3, then followed by 4. Rebel, 3p. So this is correct answer. Okay, any question you want to ask? No, okay, let me understand. Okay, understand, then we go further for the following part. The following part will ask you about the quantum number of the electronic configuration. Okay, this one just now the lady asked a question. Now we verify it here. Okay, for example here, based on the electronic configuration of sulfur, give the 4 quantum number of the last core electron at ml equal to +1. Wow, you say, wow, how we know it? Be careful. When we refer to here, you must know what is the core electron. Where is the core? So we know that this one refer to the valence electron. Then leftover is under the core. The core. Okay. It's stated there the last core electron at ml equal to +1. +1 means what? Mean refer to 2p. This is 0. This is -1. This is +1. Okay. Then which electron refer to? Then you say, hey, Mr. Lim, how do I know the electron will be? This is the first electron allocate. 1, 2, 3, 4, 5. Last one, this one. This one allocate. Now we write down the last core electron for quantum number. Okay, you can write in 2 formats. Either you can put bracket, you can write it directly. For example, N followed by L, followed by ML, followed by MS. Can okay, so we can write out the number. Yes, n equal to 2. Sini, this one. P representing by 1. ml plus 1. ms, lower spin, upper spin. Lower spin because for facing down. Put right, negative, half. This is the first format. Second format, you can choose either. You can write down which is n equal to 2, L equal to 1, ml equal to plus 1, ms equal to negative half. Up to you. Without bracket, doesn't matter. Okay, choose either one. So which one that you prefer, choose that as a format. Next, the first valence electron. Now you try. I give to you 30 seconds to write down. Let's try. What is the 4 quantum number of the first valence electron? Some students say, yeah, we know. Go ahead lah. Like, never try, never know. Done? Done, okay. First valence. So you must know about which one is a valence. Valence refers to the most outest n number. Number 3. 3. Then this is a valence electron. The first. Which one is the first? Some student will choose this one. I say, no, this is not the first. Which one the first? This is the first. So this is the first. And then we know refer to 3s. Then you can start to write it down. Yes, first one, 3. What's the L number? L refer to the S. S representing by 0. Okay, S0, show that ML will be 0. Then upper spin. So put positive half. End the story. Can? Okay, open for question and answer. Come. Okay, I have to verify one more thing for you. Listen here, listen. Okay, sometimes some question they give based on the electronic configuration of S, give the 4 quantum number of the first, okay, listen, the first electron of 3p subcell. Okay, listen, if let's say this question come up, quickly raise your hand. This question consider question mark. You cannot answer. Why you cannot answer? Because it refers to the 3p subcell. Sini, this one. When you want to write down the electron itself under the 3p, actually, listen, the first electron can be allocated over here. Can be. It also can be here also. It can be here also. Because why? Because according to the hard rules in a quantum number, in the same of the 3p subcell, all the energy will be considered the same. So that's why the electron can be allocated at any of the first here in the orbiter itself because they're having the same energy level. So that's why if let's say the first, you can choose this one. You can choose this one. You can choose this one. Cannot be the answer. So that's why when a question come out, I must verify just only one answer rather than 3. Because students will keep going, Mr. Lim, how can you got 3 answers? How we write? Because we are not following the rules that we have. Understand? So that's why I selected for you the last core electron number of ml equal to +1. It's just only one answer here. Because I asked you to write down in +1. You cannot say, Mr. Lim here give to us +1, here 0, this is -1. What? No such way. Because under orientation must be -1, 0, +1. You cannot simply change. Understand? Also, I said that 3s, I say the first. You cannot say, Mr. Lim, this one also can be what? I said, no, this is the second. The first mean must be upper, then followed by the second. You cannot choose that one as the first, tak boleh. But in the 3p, can be. Yeah, so that's why in the 3p subcell, if let's say you want to fill in electron, it can be 1, 2, 3, then 4, 5, 6, doesn't matter. We will accept your answer. Yeah, but normally during exam, we won't give to you some funny answer to provide. We won't. We choose for those more logical way. We said that show the full subcell 3p of the electron. You show overall lah. Get it? Okay. Any question before we proceed?
Teacher, if there just stated the last core electron, then it is referred to the last core electron at ml equals to +1, right?
Yes, correct. Yes, correct. Okay. If let's say I put there the last core electron, I didn't mention here, I didn't mention ml equal to +1. You got 3 answers. You can select this one, you can select this one, you can select this one, because they got 3 under the same energy level. You can put simply which one the last, also doesn't matter what. But I specify ml equal to +1. You just only one answer. Okay. So let's say I come up with some of the question is so funny, you quickly raise out your hand. Mr. Lim, this question got 3 options. Normally, if let's say 3 options, we give to you 3 marks. 3 marks, I mean the mark will tell you each answer will be 1 mark. Okay, and also, I give to you the electronic of S with the last core electron with the number of quantum number S over here. So you can able to get know lah. Is it the answer will be the single or maybe more than one? This one normally I will guide you during the revision. Okay, revision. I will give to you revision as the same way. Okay, any more question before we proceed? No? No, okay. Now that we go further. Yeah. Now look at here. Now we have to know about the principle when you fill in electron. Which of the following is correct orbital diagram for the ground state of configuration phosphorus? Z equal to 15. Z equal to 15, neon equal to 10. Left over 5 of electron over here. So when you go for 1, 2, 3, you must know which one is correct, which one is wrong. It's wrong, how you answer it. Can? Okay. Before this, we proceed to the lecture notes. I will tell you more detail. Okay, here. Okay, the rules that we have are Aufbau, Pauli, and Hart. They got totally 3 principles. So now we directly go to Aufbau. Aufbau stated there, okay, they got 2 points. You must mention each point there based on the case. Orbitals are filled in order of increasing energy. This one is the first point. You might having the way. So that's why when you fill in electron, 3D and 4s, you must fill in 3D first. You must fill in 4s first before 3D. Because of why? Aufbau principle stated here. Have a look. See? These are rules you must follow. So if let's say I give to you some of the case, which is I fill in 3D first, 3D can go for 10, then 4s equal to 1, there's something wrong already. You know that this one against Aufbau principle. You quickly write down Aufbau principle, then followed by the reason. Why? Because it's stated here, electron fill in based on the order of increasing energy, 1 mark. From what? From the lowest to the highest level, another 1 mark. Okay, then afterward, some students say, Mr. Lim, how about the second one? We have to write down or not? Better you write down, because why? You must build in the subcell itself in order in increasing n plus L number we have. So means what? So mean if let's say 3s and also the 3p subcell, you might having 3s first. 1, 2, then followed by 3, 4, and followed by 5. Okay, you cannot having the answer which is 3s, you're having 1 electron. Then afterward, you go for the 3p. 1, 2, 3. This one against the second part already, which is the subcell rules. Okay, so you stated both of the answer in your test. So we give to you full mark, 3 or maybe 2 marks. Done? Done. Okay. Next one. Some students say that, Mr. Lim, I'm weak in remember for it. Okay, if they say you can follow the sequence over here, you just only remember until this one, then you can stop here, 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 in your syllabus. Okay, you just follow the sequence. Okay, 4P, 5S, not in your syllabus. We won't ask you. Then furthermore, 4F and so more. 4F just only come out in just only one in topic number 4. Topic number 5. When we study about lab PB. Only one. But don't worry, it just only show to you what is the reason that the tin, we call the lead, considered non-stable. Okay, just remember for it. Okay, now we proceed to the following. Okay, any problem about the Aufbau principle? So far? No? No? Okay, now we proceed. Okay, this is another way how to remember. Remember, just only remember the part of here. Enough. Okay, the rest, do not. Don't need to go further. Okay, I studied chemistry for 30 years. I never studied until 7I. Never. This is a very dangerous element. Okay, now we go to poly. Poly exclusion principle. Please remember they got poly with exclusion. Don't put poly only. Poly, no, without exclusion. Sometimes we put question mark. They say, where's the exclusion should be? Okay, in poly, they got totally 3 parts you must remember, which is no 2 electrons in the atom have the same set of 4 quantum number. It means what? For example here lah. For example, in 3s here, you put the electron here. Mana boleh? Because of why? In the 3s here, this is the 4 quantum number for the first, which is 3, 0, 0, positive half. Correct or not? And this one also 3, 0, 0, positive half. They are same quantum number. Cannot be. Tak boleh. So they mean you must having 2 different set, or maybe not all the 2 sets have the same 4 quantum number. Then non-atom orbital can contain more than 2 electrons. So funny, student can draw this one. 3 electrons, they draw this one in the same of the orbital. Tak boleh. Because of why? You're against the rules of Pauli exclusion principle. Next one. Each orbital can hold by 2 electrons with spin pair. Spin pair opposite, upper and lower. So that means you can choose this one and you can put this one, 2 answers together in the same question. Understand? Do only write one. Write one, maybe the question will give to you 2 marks. This one is 1 mark, another mark over here. You just only write one. Sorry. Okay, this is under Pauli exclusion principle. So once again, if let's say 3s having the same of the spin, so please write down 2 answers. Answer number 1 and answer number 2. Any question? No? No? Okay, now we proceed. Okay, hard rules. When there is a cell of orbital is equal energy. See? Equal energy, this one refer to the same subcell. Same subcell. For example, 3p. Then we're having electron. Each orbital become half filled. Half filled before any of them become completely filled. Means what? Mean you must having 1, 2, 3, 4, 5, and 6. So if let's say the question come up is here, 1, 2, 3. Sorry, my writing pad. 1, 2, 3. This one is the rule that against. This is the rule that against, which is not under the hard rules, which is by having the equal energy, fill in half before you complete the fill. Understand? But however, some student, this one you put as a Pauli exclusion principle is considered wrong. This one, if let's say you put here is a Pauli exclusion, sorry, wrong concept. Next one. The most stable arrangement of electron is with the maximum number of unpaired electron with the same spin direction. So this is the same way that we can draw, which is 1, 2, and 3. If let's say the question come up in here. I do 1, 2, and 3. Here. That's a problem. Be careful. Don't assume this is Pauli exclusion principle. This one undergoing for the hard rules, which is the stable way must having the same unpaired electron with the same spin direction. It means all must be up before you all become down. Okay, but somehow some students ask, Mr. Lim, how we know that is the differences between spin and the hard rules and also the Pauli exclusion principle. Listen. Normally in the hard rules is under the subcell, which is 3 orbital or 5 orbitals. But in the same of the orbital itself, they come out with the same of the electron. This is under Pauli. This is under Pauli. If let's say under 3p with the 3 orbital, the electron, we can see that difference of the direction for the spin. This is under hard. Okay? Okay, any problem so far? No, No, okay. No, then we're back to the question just now. Okay, come, tell me. This is under which principle? Which one is not? Which one is not? Okay. Among here must be one correct. So tell me which one is correct?
The second one.
The second one, set 1, set 2, and set 3. Okay. Some students say set 2 is correct. Okay. How about here? Later we go for another set. Any objection? Set 2 is correct. Okay, correct. Just write down correct. Okay. Now, number 1. What is the rules that the answer is against? Pauli, hard, or off-bound? Anyone can tell me?
Pauli.
Pauli, agree? Pauli, let me see the answer. Yes, Violet for the Pauli exclusion principle. Yes, Pauli exclusion. Why? None two electron with the atom can be the same 4 quantum number. As I mentioned to you already, you can see that under the same subcell, the problem over here. But let's say under another one, 3p is undergoing for here. For example, here, this is under hard. Get it? Okay, so then write down point number 1. Each orbital can hold by 2 electrons with a spin pair. This is another point. So you can score. This one having 2 or maybe 3 marks. Go ahead. Any problem so far? Can? Can. Okay, now we proceed. Number 2, correct. Number 3, tell me which of the principle against? Which one?
Hans rule.
Hard rules of hard principle. So we check. Yes, hard rule. When? Because when they are set of orbital equal energy, each orbital become half field before then become completely field. Yes, correct. So this one give to you 2 mark or maybe up to the mark should be. Can? Okay. Maybe write out the answer. Maybe capture it. And why you can replay the video. Okay. Now next to set number 4, number 5, and number 6. Any mistake? Any correct electronic configuration?
No.
No, no. Okay, now we proceed. So number 4, what is the mistake? jump directly, all the electrons for the 5 go to the 3p, not go for 3s. So this one again, which rules?
Outbound.
Very good, outbound. Okay, outbound. So orbital are filled in order increasing energy from lower to the highest level. So subcell in atom are filled in order of increasing m plus the L number that we have. Okay, number 5. Okay, come, number 5. Anyone can answer?
Pauli's exclusion principle.
Which one? Which one? Which one? The rules are not obeying.
3S.
No. What I mean is hard rules, Pauli exclusion, or outbound.
Pauli's exclusion principle.
Very good, Pauli. Because why? What's the reason? Can somebody give it answer? Why Pauli? Because
Each orbital can hold up to 2 electrons with spin paired to opposite spin direction.
very good. Okay. So yes, it's under Pauli. Okay. So you just only go for the reason. Fine. Okay. Last one. Number 6. Which one? Hard, outbound, Pauli exclusion.
Hans rule.
Very good. Okay, Hans rules. So Hans rule, when a set orbital equal energy, each will become half sphere before any of them become complete field. Okay, don't put poly because it's not under S subcell. It's under the 3D or 3P. Yeah. Okay. So far, any question you want to ask? Open for you. No, No, okay. So if let's say no, so we just only have to conclude everything that we study from the first lesson. I really appreciate because you can attend it, but only have to remind you some of the part you must know. Okay, for example, once again, in the way that of the orbital we call predictable, you must verify is which element it refer to. You just only have to remember 3 blocks: S, P, D, not F. Then 2 formula must be applied, and be careful, it must be from joule, then become kilojoule, and can be kilojoule per mole but involve the Avogadro constant. Then which formula can be applied? Must clear about it. Some book they put H mu, somebody will put HF. Up to you. Yeah, say. 4 of the quantum number must know and also how to apply. 2 formula using it to calculate orbital. Be careful, orbital or electron, you must verify it. 4 modern outbound Pauli hard rules we cover already in chapter number 1, followed by this table. Now you know already how the powerful of this table. Okay, so you can able to using. And this one actually is a game for you to understand what they are talking about. They are using here to tell you what is the element should be. Okay, you got some gold, mercury, or cesium or whatever. You can understand what is happening over here. Okay, so once again, in here, the learning outcome, you can see that how we apply the principle of inorganic chemistry, and based on that, we can able to answer. How you know you understand or not? Quickly go to the selected question for tutorial, you try to answer. And let's say you can answer without refer to the notes, congratulations. That means you can overcome, or it means you totally cover for this topic. Okay, student over here, I wish that can you WhatsApp to me and tell me, do you understand based on here? If let's say yeah, and anything I'm going to improve, please WhatsApp me. Okay, my contact number 012 264 8089. Do tell me roughly. If let's say anything I'm going to improve, do tell me so I can able to go for and conduct it for the next lesson. Okay, so thank you very much for your attention and enjoy your night. Thank for your attendance.
Teacher.
Teacher,
Yep.
sorry, teacher, can you show back the last slide for the just now the violet, the principal one? I haven't taken picture.
The violet principle, which one? Is it?
The set 4, 5, and 6.
Oh, you not to take the photo. Okay. Here.
I just want to recap back. Usually for electron configuration, for orbital box notation, we usually write the order in 1s, 2s, 2p, 3s, 3p, 3d. But for the outbound principle, since it's 3p, 4s, Sir mentioned something. What was it?
Okay, if let's say you the number of electron which is go to 4s or 3d, okay, let's say so then you must having the arrangement by 3s, 3p, 3d, then followed by 4s.
Okay.
If let's say you want to further, you go to chapter number 9, subtopic number 1, they will tell you how about the arrangement.
Okay. Thank you.
Welcome.
Teacher.
Yep.
May I know what is actually ground state? And is there any example?
Okay. If let's say under a ground state, okay, let me see ground state. How I answer you? Okay, let me do a check from the lecture notes. I do tell you about it later because I also confused about something already. Okay, are you Kenneth?
Yeah.
Okay, you text me once again, I will reply you. Okay.
Okay, thank you, thank
The
you.
rest of students, don't worry. The ground state, this one I will reply it during the second chapter or second lesson. Okay. Any questions so far? No. Okay. So thank you for you all and good night.
Teacher, when before the lecture class, we start the lecture class, you show us to write the group. So when we write the group, we can write like 13, or we need to write 3A, 3B like this.
This one actually you can refer to the periodic table to write any number on the top there.
Both also acceptable.
Accepted.
Oh, okay, thank you, teacher.
Welcome.
Thank you, teacher.
Welcome. Good night.
Thank you, teacher.
Thank you, teacher.
Welcome.